Hello, everyone. Welcome to the MLIR Open Design meeting. Today we're meeting a bit early, and thanks folks who present and manage to attend either early or late, depending on the time zone they're in. We will have Ferdinand and Luke talk about their proposed WebAssembly dialect for MLIR. Ferdinand, I think you're presenting first, or you're presenting, so the floor is yours.
Yeah, I will be presenting, yes. Um,
Let
let
me
me
share
just,
share screen.
yes, give me a second. Not super used to Zoom. Uh, and you should see a bunch of slides in a second. Okay, do you see my screen?
Yeah.
Okay, perfect. Okay, so hello everyone. I am Fernand from Woven by Toyota. I am joining you with my colleague Jessica and Luke. Um, we are here to present basically a summary of the stuff that we've been doing on WebAssembly and discuss yeah, the designs and the implications, and hopefully find the path to upstreaming this to upstream LLVM. Yeah, I have a few slides to show you. As I was saying, should be relatively short. That just summarize why we are doing this and how we are doing this, and then we'll jump into any questions that you can have. Yeah, any topic that you want to bring related to this, we can discuss here, and hopefully we have at the end a conclusion on where to go from here to upstream this project to LLVM. The motivations are fairly simple. So currently WASM is gaining a lot of traction. So WASM is a format that is used to run in a runtime or embedded environment, and it's getting a lot of traction. And we believe that yeah, everyone would benefit from having an ahead of time compiler of WASM, or at least the base for one in an LLVM project. We know that there are a few efforts that already exist outside of LLVM project. Some relying on CranLift, some relying on other tools, or some relying on LLVM but out of tree. So all the versions of LLVM. We would like to bring this inside LLVM because we believe that we can leverage all the latest improvements of MLIR and stuff like that to benefit ahead of time compilation of WebAssembly. And there seems to be more than just us interested in this project. We have been made aware recently that some researchers were also working on a paper related to that. That's completely unrelated to our proposal, but that actually has a very similar approach to the problem. Um, yeah, so this thing we have seen also on the RFC some comments showing interest in having a way to parse a binary and then do modification on it, optimizations, verifications, all of these things. It's actually our use case. Our concrete use case is basically loading a binary and being able to modify it, optimize it, transpile it to something else, etc. So for the implementation, we have like two and a half main parts in the proposal. The first one is the importer. So we take as an input a binary. We don't consider textual file for the moment. So it is only binary. And not just for the moment. We don't really plan to implement that for, yeah, that support. We load this in WASM MLIR. So I'll go into the details of how the dialect is built a little bit later. Um, and then the second part is translating this dialect or converting this dialect to the usual dialects of LLVM, so math, arith, SCF, etc., etc., and then to LLVMIR, LLVMIR, and then to LLVMIR. And the half part is a really simple driver that we have added called Wasabi that yeah, just is a bunch of command line arguments and a path to translate a binary directly to LVMIR. So simple, yeah. I'll go into the detail of the implementation just after, but the main part is located. So the main part of the importer is in the MLIR target wasm. Um, yeah, actually, I will share. Can I share VS Code on? I'm sorry, I'm not super used to Zoom. Um, okay, I'll share that just afterward. I'll go through a full slide and then I'll share the code afterwards. Um, yeah, so the importer is there. It consists of basically a main parser that's fairly simple, um, and that abstracts all the stack semantics of WASM because we decided to represent WASM MLIR as an SSA in an SSA format. The reasoning behind this is that it makes it far easier for us to convert to other dialects of the LLVM ecosystem that are also based on an SSA format. There can be discussions around this. I have a bunch of points afterwards regarding that. The WASM dialect itself, it's a fairly simple table gen file. Yeah, currently it covers all operation from WASM spec 1, except for anything that interacts with the outside world. So that means no support for memory and imports, I think. That's all that we don't support, but everything else from spec 1 is supported, and a few operations from spec 2 are also supported. Um, the reasoning is currently we don't have backend representation for things that interact with the outside world, and I'll come to that a little bit later. And yeah, the lowering to the usual suspects, READ, CF, math, and stuff, is all done in one single conversion pass. Same thing. So reasoning here is that we could have like WASM to READ, WASM to math, WASM to CF, or something. The thing is, we don't think anyone would actually use them separately from one another. So yeah, we believe that it's just better than to have a pass pipeline that just calls the same thing everywhere. To have a single pass. And the pass in itself is fairly simple because we tried to stick to the format of what we were targeting in the first place. So most of the operation are one-to-one mappings. So it is, yeah, we believe it's fairly reasonable to have everything at the same place. Yeah, so as I was saying, the straightforward approach, having everything mapping to something that already exists so that translation are as simple as possible was our goal doing this. For imports and exports, we make use of the visibility mechanism of MLIR. So exports are not represented in the IR directly. We just set the visibility to public, and everything else is nested, basically. Which is different to what the default is, I think, of MLIR. Of an interesting feature that we have, and it's something that was actually mentioned on the RFC comments. So WASM functions have reference semantic of the arguments, so they do not behave. They mostly behave like locals, but yeah, with a few extra steps. So we have a dedicated type for that lowers to whatever type is below, but it's just to show yeah, the difference in semantic that's slightly different. I have an example of that just afterwards. And testing was also something that was brought up on the RFC. Currently, we have lead testing for everything. So lead testing for all the operators that we import, everything that we convert. We don't have a lot of end-to-end testing. We only have one, I think, which is yeah, something that we need to improve on. Yeah, I'll also go into the details of the test later. But to test the importer, we need to have binaries. So yeah, there is a file with all the inputs that are binaries, and then we have a textual representation in the test to represent what is being tested. Yeah, when we have better coverage, we will be able to make use of whatever WASM test suite already exists, which should be much better to improve our coverage of end-to-end testing mostly. The technical challenges are the things that we want to talk about mostly today, because that's things that are still in discussions or that can broaden up discussion. Um, so as I was saying, WASM is or is executed on stack-based virtual machine, and we represent it in an SSA format. That means that everything that you can represent in an SSA format is actually a superset of what can be represented in WASM. That can be slightly annoying if you want to do transformation, round trip transformation, WASM to WASM, MLIR to WASM, for instance. I mean, that's mostly should be fine, but we could have a verifier pass. We currently don't have one to verify that the SSA format follows the stack-based format. And another proposition that we've seen in the paper that was proposed a few days ago is to have another language, another dialect that represents the stack-based format of WASM. We will not be working on this, but yeah, we are open to the proposition. So if there is anything that we need to do for interfacing with that, it can be like even renaming the dialect because the WASM stack-based dialect would be closer to actual WASM. Yeah, that's perfectly fine, and yeah, we can discuss this also. One of the important topics also for us is everything backend related. So as I was saying, we currently don't have support for everything that talks to the outside world. And that's because we haven't implemented anything on this. This is still very much in discussion. So I wrote embedders here, but that can be embedders or that can be even native environments. Basically, anything that interacts with the outside world in WhatsApp should trigger a trap or something or an instruction. Um, we currently don't have a great solution, but our idea would be to have an abstract representation of this trap in MLIR. Could be in a subset of the WASM language, so wasm.embedder, wasm.something. And then this thing, when lowering at backend level, would be translated into whatever we want to target. So if we're targeting wasm time, it would be a wasm time trap. If we're targeting something else, it would be something else trap. But this is very abstract, and we still don't haven't worked at all on this topic. But this is the next thing that we want to tackle. So if you have any opinion on this, feel free to give it because yeah, we're really open to on this topic. Versioning is also something that has been brought up. So the spec of WASM is complete should always be backward compatible. So that means that everything that we wrote there should not become obsolete. And that also means that we should not need to do any versioning on the operations themselves. The only thing that can happen is that the language expands with every new specification. And yeah, that's where we'll need to work. But versioning should not be an issue. And we have one small thing about some operation of WASM having a rounding that's not represented, I think, in arith or bas. And we can talk about this at the end if we have some time. Uh, yeah, just a few examples of IR, and then I'll jump to showing some code. So yeah, this is a super simple function that just adds two operations, to arguments. And this is the type that was mentioned as a comment in the RC, I think by Theo. I don't want to to take take the praise for this one. But yeah, so it is basically just a representation of the argument, and then there is a local get at the very beginning of the function that just gets the argument from the reference and uses it. Super, yeah, that's the most simple example, but yeah, if you have any question, feel free to ask. And an example of control flow. This is also interesting. So yeah, in a simple example like that, it doesn't really show. But for control flow, WASM takes the nesting, it can take nested control flow and always knows at which nesting level it is. Something that's not super easy to represent in MLIR. So we have a way to represent it, but well, doesn't really show in this example because it's a simple single nested loop. But I'll show it in a minute. So for loop in general, super simple stuff. We have a block return at the end that returns the value and just jump to the successor block. Yeah, fairly simple representation, but again, any questions, any remarks are, uh, yeah, will be good. And that's all for the slides. I will just jump directly um, to VS Code to show you some code. Um, There I go. I this one. Yeah. Um, yes. So just quickly to go back to what I was saying. So the translate to wasm file is where we have everything related to importing a binary. We have one head, uh, one main class that is called wasm binary. No, wasm. Yeah, this is a fairly big file. Wasm binary parser. Yes, there it is. This is basically the header class. Like that's where everything happens. It loads the binary. Wasm binary is a module with different sections, and then every section has a bunch of stuff in there. So what this does is exactly that. It loads a module uh, here. It loads a module, and then it just passes the different sections from everything. Um, Important stuff mostly is the code section. The code section there is where all operations happen, and this is also where we abstract the stack machine that I was talking about earlier. And this actually calls pass code, yeah. And this calls pass expression. Yeah, and this pass expression actually just dispatch everything to all the opcodes and anything that we define. Where is the stack being abstracted? If you ask, it is in the expression parser. And expression parser, and we have it is really simple. We have a value stack in the class that just keeps track of all the values that we push and pop. And yeah, we just pop operands, push, yeah, pop operands every time we run an operation and push the results so that the next operation can consume them. This is for the importer. What is important in the conversion? Not in this one. This one. Um, Most of the stuff is one-to-one transformation, so we have basically templates and then really simple instantiation of every operation. But one of the important thing I think is the control flow, and that's what I was talking about earlier. So because we need to keep a state on knowing like where in the nesting we are, we decided to have everything being passed at the same or being converted at the same time. So during conversion of the function operation, we actually go through all the control flow operations and we inline everything with a branching to where they were pointing out in the first place, so that it makes it much easier for us to represent afterwards. And this is where it happens. So for the blocks, the loops, and the if operation, and I think that's all the control flow that we have. Um, yeah, this is the complex part of this, but otherwise the rest of the transformations are very simple. It is a bunch of function representing everything. And as for the test part, let's take a simple test. So yeah, this is what the test for the importer looks like. It is super simple. It just has this binary as an input that we store just there. And this, so yeah, I dumped the textual representation so that we know actually what we're getting what we're testing. And Yeah, super simple test, and we have that for every operation, more or less. I mean, every operation, maybe some of them are grouped together, but yeah. And same goes for the testing of the conversion. So, for instance, the loop has a bunch of loops, a bunch of tests, and we have that for every other operation. Um, Yep. Is there anything else that I wanted to show there? I don't think so. Yeah, maybe just a quick look at the driver, but it is super simple. It just takes uh the output form, like output level at which we want to output the IR, and the input type if we want to load WASM MLIR or WASM, and has a simple pipeline with everything that needs to run to go to LLVMIR. And it has yeah, one simple test that loads this module and dumps at every level, like at WASM level, at LLVM MLIR level, and at LLVM IR level, the IR generated. And I think that would be everything that I wanted to show. So yeah, if you have any question, any remarks, anything that you want to bring up, now is the time.
Okay.
I just say, like, thank you very much. This was a nice presentation. I'm sort of curious about. So you mentioned there's the one lit test, and you've mentioned also the conformance test suite. What sort of currently you're thinking about? You know, how could you use the conformance test suite in testing here?
I will ask Luke about that. Luke, can you jump in for that? Because I haven't looked at all in the conformance test suite of WASM, to be honest.
Yes. So the conformance test suite, you have a few just binary, how to say, stuff that say, okay, you should be computing this end to end and check the result. For performance, at the moment, we don't have ideas on how to check it, but uh, yeah, we can compare to the, how to say, have benchmarks, but it would probably not go into the tree for the development. It would be a side project to compare multiple implementation and not embed everything in the development.
Yeah, no, I think that would be useful. I mean, like even like some of the questions on like you know, like a different bolt bot or some automated process for tracking along the way. I think it's useful, you know, but out of tree. Um, the is one of the sorry, I missed the beginning. You may have mentioned this. Is the is there any intention of keeping the like sorry, WASM input, WASM output? You imported, you exported kind of category. Is there any intention to keep it similar, or is this all WASM in being able to compile it down to like LVM execution, or sort of like you know what is the goal for like the dialect and the representation, and what do you want to retain? What would you not care about losing?
I mean, we don't really care about staying true to WASM. We don't. I mean, we can generate. I mean, generating WASM out of it is a use case, but generating LLVM, IR, and whatever downstream thing is also a use case. So we don't really mind getting further away from WASM.
Yeah, basically, I'd say you have two types of usage. So one of them is ahead of time compiling of WASM files. So you don't care actually to lose anything about the WASM structure or stack machine. You still want to keep the, how to say, the sandboxing features and the checks of safety and so on, because this is important for your user. But basically, you want to generate something that keeps the safety but is more efficient, and you don't need to duplicate the expression tree or whatever. And then you have also so this is more of the use case of the research team, which has been publishing a paper recently, where they say, okay, actually, if you go from higher abstraction level, you can generate better WASM from the first place. And then I guess in this case, you want to generate a good WASM and have WASM as an output of your compiler, because then you feed it to the browser, I guess, or whatever. But our use case is mostly to produce a native code in the end. So I don't know if it answers your question.
No, it does, because I sort of wanted to, you know, like in the process of change from the stack-based form to the SSA form, I mean, you may lose some information. I wasn't sure, what you want to retain there. So no, it does make sense. So one random comment that may or may not be useful. So in MLIR, we actually have the ability for a dialect to say, you can align the prefix of the dialect inside the ops. So for example, for your WASM ones, you could have it like your wasm.func, and inside you don't need the WASM prefix anymore. In case it's useful,
Okay.
but then you just have plain return, plain load, plain whatnot.
Yeah,
So
that
it
would
may
be
look
more beautiful, basically. So that would be a good idea.
Okay.
yeah. So I'll give somebody else a chance. I'll go back to one of the slides where you had like a question on like the trap, but I'll first give somebody else a chance.
Yes, there is a question in the chat. I'm not sure if Harsh is able to speak. So if not, I can read that. Just to be clear, after the WebAssembly is lowered to the respective MLIR dialect, further lowerings will be able to essentially give WebAssembly access to MLIR and LVM optimizers pipeline. Is that correct?
Yep, this is correct. Yep.
Yeah.
Okay. Yeah, I had a question that's also related to testing, so we can speak on that because at some point you mentioned most of the your main goal was to consume WASM binary. And I'm thinking about how do we test that because I'm not really willing to put a bunch of binary blobs that we use as tests. So what's your thinking on testing?
Yeah, that's something we haven't found a solution for. So currently we have a bunch of binaries that are fairly simple, but the moment we have a long bigger stuff. Oh, Hannah as a remark. Go ahead.
You actually don't need a binary. You can have WASM texture format to do so.
Yeah, but
but we
the
don't
problem
have
was
the. Oh, sorry. Like we just don't have
no.
the parser for the textual format right now, and I think that Ferdinand mentioned earlier that we didn't really have plans to like implement the textual format right now. I think that there's a lot of value in doing both, honestly, because that they're both the canonical formats for WebAssembly, but yeah, we don't have that right now.
Yeah, I mean, something else that we could do is having a dependency on another tool outside that would just compile the WebAssembly, but that adding a dependency on the test suite is pretty annoying, and I would totally understand if people push back on that.
I think someone also made the remark that we could be doing some round trip to test the validation. But at the moment, we don't have an output translation for producing WASM back. So that's also why we are interested to work with the research team that published this specific paper we were speaking of, because they were interested in that. So probably they do have a translation from MLIR to WASM binary back. And so that would allow the translation basically.
Yeah, so just to give you some more context of why I specifically care about this, I have multiple downstreams that I either manage or contribute to, and they pull a new version of LLVM, like, I don't know, depending on the project, between every day and every week or every month. And if something breaks in LLVM, we will have to go and see what is broken and how, and probably send the patch, and it might be in the middle of the night for people in different time zones. So having some sort of consistent tooling really helps with that. And so far, consistent tooling for us was file check. So like we put as much test as possible in file check, and if something went wrong, at least you know where to look. So like having some, I understand there's probably like a two-level testing strategy where there are unit tests for very like small primitive constructs, one op or a sequence of ops, and then there are more integration tests where you have a full function or full program in WASM that can be binary, and that should go to something that we don't have but should, like MLIR test suite. That could go there, but having some way of testing it in a way that it aligns with everything else in the code base feels pretty important.
I mean, we are using file check right now for the tests, actually. Like we do have lit-based tests for conversion from the binary format to the WASM dialect, that we have lit-based tests for each of the conversions, like the translations from the WASM dialect to the core dialects, because we've been kind of trying to follow the LVM and MLIR development style the entire way through. And personally, I get really, really uncomfortable when something doesn't have a lit test. So it's very, very important to have that. What we don't have is something like the LVM test suite. So we do need to have something like that. And it certainly would be a lot easier if everything was textual all the way through. Right now, we do have to have binary format WASM files stored away somewhere to prove that we can translate them to the WASM dialect, which isn't great. But that's also not unprecedented in LVM, because if you like go and look at like the object file related stuff in LVM, there's like a ton of just like terrible binary files sitting around in like the LVM repos that are just like, here's like a handcrafted broken Mako or whatever that proves that LVM obj dump emits an error message on this thing. And they're not ideal. Like they're definitely painful. Like when people have to change these tests, like somebody who knows how to create the object file has to like update it or change it or do whatever potentially, which is like not great. But I would say that we do have like a pretty standard testing methodology that isn't actually too weird considering the rest of LVM.
Yeah, and if I can add to that also, it is super easy to recreate them because you just put the source there, so you can just regenerate them if there is anything that goes wrong with the binary itself. The source is there, so it is
Yeah,
a one line there.
I think that is reasonable. Like I understand it's not unprecedented. Just I'm trying to reduce the pain for
Yeah,
maintainers, and like
I
I'm being
understood
selfish. I'm
that.
the maintainer, and Jack is a maintainer. Like I would love to understand how it works. I might not have time.
Yeah, I mean, I think a good thing at least here is sort of like the parsing is, I would say, reasonably constrained group of people that will be hacking on it, or there's not an MLIR generic change that will affect the parsing beyond building attributes, etc. So, you know, I think that gives us some breathing room here. I mean, I think it's a, you know, that's sort of why I mentioned like also like out of tree, test suite, etc., etc. As long as you can find these things easy during this initial period, I think that'd be good. Of course, having it upstream is the best because then folks can break you on commits. So, but yeah, if there's some idea on like the textual format, I think that could actually be quite nice. I
mean,
don't actually even know.
What's a tool like? How big or like otherwise undesirable is a tool that goes from textual format to binary?
Yes, that exactly is the other question. I have a Chrome tab open on that as we speak. So actually, I don't know. Yeah, how big is such a parser? You know, how complicated is
They are
like?
fairly simple, but yeah, I mean, how big is quite vague.
Okay.
But yeah,
Okay.
I mean, in our case, we're using Wobit that just have like a binary that goes what to wasm. It is a super simple
Let me
binary.
rephrase. How much time it will take to build the tool from scratch on a CI machine?
Oh,
Or can
super short. It's super short. Yeah.
I think that is part of the solution is to have, well, if you want to regenerate this, like we can either run the tool or say, well, here's how you regenerate these tests and have some upstream, because like I do agree that we want something that's upstream, but we need to find the right balance. And some of these are like, sure, we can start committing things as they are, but over time evolve to a more consistent strategy with round tripping and something if people keep contributing.
Yeah.
I think it's pretty simple to build these actually. Like I think I built like wat to wasm and wasm to wat like in a few seconds on
Yeah,
my
it is a super small binary. Yeah.
Yeah, but like also it'd be cool if we actually had similar tools like in LVM somewhere. Like I know that we have things like obj to YAML, YAML to obj and everything. So like having similar translators. I don't know if it's valuable though, because like the wat to wasm and wasm to wat or whatever tools work completely fine. So like why reinvent the wheel? But they exist, they're very small.
I
Well,
do think it could also be anyway valuable to the Clang WASM backend if they had the translation stuff to be able to check the equivalence or whatever. So could be used also in other projects, basically. So and actually maybe
So like it might be worth bringing this up to like LLVM overall project and say, how about we either adopt one of the tools somehow or copy, like I know LLVM hates external dependencies. Yeah, things tend to change this in the recent years.
Yeah, I mean, I would say things like, for example, we technically have NumPy as a dependency for some of our tests, right? But it's not a repo dependency, but it's just in our testing one. So yeah, I think that there's some. It's an interesting topic. I mean, I'm not, it would be a discussion, but I don't think it's an unreasonable one. And I think the point about the usage of the like the other backends and WASM side and Clang side is actually very valid here as well. It's a good additional point.
Yeah, I mean, I think that's just worth bringing, like going to discourse LLVM and asking there, and maybe you'll have like overwhelming support from Clang saying we do need that, and there's no problem at all. It's worth starting the discussion early, I think. We shouldn't block this discussion on that one, but it is worth having that separately. I have several other, like some questions, some comments. I would want somebody else, if they have questions or comments, to jump in. Arash asks in the chat what kinds of optimizations would be possible to apply on this dialect directly.
So basically, we would be able to do some kind of constant folding or sub-expression elimination because we go from, how to say, from stack where you might have multiple expression recomputed to make the stack machine happy. And if you realize that you are recomputing the same thing, that because for whatever reason, the backend produced a WASM that doesn't use variable, you could be doing that and so on. So there's already some optimization that you can do at the dialect level. Don't know if that's answer the question.
Looks like it does. We will see if there's more response in the chat.
Okay.
Yeah, I think that answers the question. Thank you. So let me take one of the others I had. Yeah, I think it's mostly out of curiosity. I guess I know the answer, but at some point you mentioned that arithmetic and math operations are pretty similar to arrays and math.
Mm-hmm.
Have you considered just using arrays and math directly?
So we did, and the reason why we are using this is because we basically want to have control on which specific type we want to allow the operation to work on. So WASM doesn't support, for example, addition on I-17, where array does. So we would have required to have validation, and it doesn't help, how to say, was deemed to faster to actually just restrict the types of the operation instead of having validation that we don't use invalid version of the arith operations.
Yeah, so just to give more context, we have arrays and math, and we have an LLVM dialect. Basically, there is a lot of overlap between LLVM dialect and arrays. And I don't think we have consensus on whether we actually want to maintain that or not. So I'm basically looking for data points and people who had similar problems, like why do they do that or not do that? And there is cost to that. So for example, if you had used arrays, you would have automatically benefit from all of the foldings and connectorizations you have for arrays.
Yep.
And then
Yeah, I
otherwise,
mean,
like
we use that, but after converting, basically. We run canonicalization just after conversion.
yeah,
So
fair enough. It's just that as a joke, I said, like, yeah, it's nice to have interfaces, but I really don't want to write an arithmetic addition op interface.
So like, why doesn't arith have rotates?
As what, sorry?
Why doesn't arith have rotates? Because like that's one of the things, like there were some operations that we found that like arith and math didn't have. And when I ran into this, I started thinking like, oh, should I like add a rotate to arith? or should I not? And then like I did a bunch of digging into like why like LVM doesn't have rotates, and then I found out about the funnel shifts, and then I like talked to like Fabian, and he's like, oh yeah, like this came up as well. Like people didn't want rotates in LVM, and then they came up with funnel shifts because it's closer to hardware and it abstracts more on stuff. And then I kind of just thought, okay, well, you know what? We'll just do this in WASM and then we'll decompose it into, you know, operations in arith instead, because that seems like a better path. But like, I was just
Yeah, the
like kind of
answer,
wondering,
yeah, the
like,
answer to that, nobody needed it enough to push on implementation.
right, okay, okay, fair.
Arrays has some cost in adding stuff, so you'd have to go through an RFC for every operation, every group of operations you add, and it's like it rather long. Like we would have to do all over like all of this again for adding two ops. So if
Right.
if you are motivated enough, sure.
Sure. So
Any other questions? Because I have mostly comments, and then we can discuss a bit on the upstreaming. So at some point there was a mention that having a convert wasm to a particular dialect as a pass does not make sense. As somebody who added half of the convert something to something passes, I agree. Those are basically test passes. The point of those is to independently test a part of the conversion without like affecting other dialects. They're not really intended to be composed in a pass pipeline. The intended use case is actually you collect all the patterns and apply them once. So I think that was actually the right decision. What else? Yeah, versioning, you mentioned it in the end. There was a mention of corner cases with floating point on arrays. I think a lot of arrays was done as, oh, we need an arrays plus, and we also need to build the rest of the compiler. So how about we postpone any discussion of all the floating point weirdness and other overflow in integers semantics until later? Well, later never happened. So
like
if you see,
how does any of it work then, actually?
it works by saying whatever the LLVM semantics is.
I see.
It's like
Okay.
implicitly propagated to arrays. It's bad, but it is
Okay.
how it works.
So, I mean, like, I think we should document it maybe like as a part of upstreaming this. Like, if there's things where they say, hey, like specifically in like WASM, this is like got this specific rounding behavior or something. It'd be good to know if like we could assume that about arith or math or wherever this comes up. If not, then okay, we have to do something different. But like right now, I'm just kind of like, all right, I'm going to assume that this looks LVME, and I'm going to assume that WASM looks LVME because WASM is also partially developed by LVME people. So maybe they've come to the same conclusions, but like it's not really clear.
Yes, so what I would suggest is you can even, like, if there is something that's unclear about arrays, you can, as you go, either clarify it yourself or like go to the forum and ask, or just send the PR and say, well, we want to clarify it this way. Maybe everybody just agrees. I think everybody just agrees.
Like
Jacques?
I'm inclined to just say like send PRs as we do stuff and we've checked that the behavior is how we expect it to be, and then just be like, all right, let's improve the documentation of MLIR while we do stuff.
Yep.
That seems the most practical to me personally. And then if
Yeah, that
it's
sounds
not,
good.
yeah.
Yeah, no, I think that's good. I mean, I think one in this discussion on like math and the ref and whatnot as well is actually the point about like versioning of the WASM side. So even though there's a duplication here, there is potentially a value in that duplication in terms of being able to decouple, from like sort of like I can phrase it. You want to fix semantics at a specific level where the other ops may still be changing, LVM still changes, RIF, etc. still changes. So you may like this decoupling actually is useful to provide some layer of stability that you need for like the WASM side as well. So I think that there is other reasons to do the duplication or to have the different ones than just this. But yeah, definitely updating documentation and the semantics I think is very valuable.
Yeah, and there is a bunch of people who are interested. Unfortunately, most of them are from academia. They're not particularly keen on submitting PRs, but I've had multiple discussions like, oh, your integer semantics is all wrong and your floating point semantics is all wrong. And here is the paper on how you do semantics. Like, yes, sure. But can you please submit a 3-line change to LLVM? And I'm like, no. But there is definitely interest in that. And yeah, I think that was the original motivation why we had ops duplicated from LLVM with the point that we could evolve them differently than LLVM does. I don't think we ever did, but that was the original motivation. Okay, I don't have any more overall questions. I have some very specific questions, but I think I would rather discuss those on a specific PR. So maybe let's talk about upstreaming. I think, well, in any case, the official decision on accepting the dialect is not made in a call, it's made on that forum. It looks like there is enough support. We will like call out for people that like speak now or remain silent forever. And then we will see. I think it's the area team decision to approve that. I think we'll see. Nobody did that since we have the area team. For the upstreaming, I guess, yeah, we need to find out a way that minimizes effort on both sides. I'd like to be able to review at least some of the things on like design consistency, mostly about ops, basically because we've played with more ops than there are upstream, and some of the decisions are common and some are not. And having some like consistent, like basically people who are familiar with MLIR should be able to write WASM ops in MLIR without thinking too much.
So you said being able to review, so that means that we open a PR with everything that we have right now, like one big PR with 100-something commits. Because that's one thing that we were wondering about. That can be pretty big and pretty overwhelming for people to have such
Yes.
a PR, Lindy.
Yeah, I would prefer that to be staged somehow. Now, I don't know how it is for you. Like, I understand you have multiple commits. Like, what is like, do we slice it by commits? Do we slice it by directory?
Yeah, if the thing is, if we go by commits, like we have a bunch of history on how it was implemented, and it's like a pretty long list of commits and stuff that has been improved, and so it doesn't really make sense. But by slice, that means rewriting also the full history of commits that we have right now.
I think still it makes more sense than going by how to say by directory, because by directory you still have to have a full view of all the ops to understand what how to say they are kind of coupled because they share the shared dialect. So what we can try to do is have a review of the history and try to point, okay, there is a big design change from here. So we have been implementing all these ops with the old design when we had a stack in the design or whatever, and then it changed at this point. So basically you have the op specification. We can say the op specification changed at this point, and these are the kind of start of place where the design was, how to say, the overall dialect design was determined, the current one basically, but then probably the commit we tried to go up by hop. So yeah, you have one commit that will add the add, one commit that will add the sub, and so on. So it's probably very simple commits to review one by one. So I don't know.
Yeah, I would score something like, I don't know. Do you have an estimate of how much code that is in total?
About 10,000 line at most.
Okay, so like if
without
you
counting
can,
the tests.
okay, if you can do like 10 commits of 1,000 lines, I think it is manageable.
So actually, one question as well, like how big is? So I think the parser is also pretty big, right? Like there's the dialect parts, and I mean that could also be like a different way, like on the components, because like the parser, even though it's big, it's probably relatively uniform in its parsing style. Like, so it may not, it may sound big, but it may actually be not that terrible to review in one go, just because it's a very, structured thing.
You've also all senior enough. Make commits that you would want to review, basically. Don't do mega commits. Don't do like ravioli commits.
I think like my personal approach to this, I mean, I don't, however people want to do this, do it however you want. But my personal opinion on how to do this would be like, let's break this down into the components that we, are using to compile WASM to the dialect, and then raising the dialect to the core dialects. And then just say like this patch adds whatever for the parser, like just like the skeleton code for the parser, a simple thing. And then from there, like you just add on the rest of it. And then if you need to reference the history in the PR, then you just say like, if you want to look at the history of this, here's like some commits or whatever that show where this happened. And then the actual commit history in MLIR will actually look pretty nice because it'll be like, here's the skeleton code for, the initial parser. Here's like a simple example of it, and here's the rest or whatever. And when somebody's like looking through the history to try and understand it, then maybe they can kind of like pick it apart that way. Like I just think about somebody who's done a lot of Git archaeology and everything, and like I generally want to have something useful in the history, but also because we've evolved the design a few times over the course of like actually implementing this, there's like a bunch of stuff that maybe isn't super useful for somebody who's jumping into this project. So that's how I'd approach it. I think it's like a little bit more work than other approaches, and maybe that's not feasible, but that's what I'd like to see if I was looking at a nice, beautiful, pristine Git history.
I mean, that sounds like a good idea to me. I mean, it's extra work for you, but that sounds lovely.
I would like that if you're proposing.
Really depends on how much work it is, though. Like, I mean, if it's like actually an unreasonable amount of work for us and we look at it, we're like, I'm sorry, guys, we can't do it. Like, I mean, that's different. But if it's something that we could do, I think it would also help us in the long run when we have to like go back in time and try to understand how something fit together.
Yes, I think it's doable.
Yeah, it's also like it's an iterative process. It's not unlikely that somebody comes and says, please split this commit into two. I don't expect that to happen up front, but it's not impossible either. So yeah, because like one thing that I haven't looked much at the code, I had like specific example about how you model loops, because that's just interesting to me. I'm not sure I correctly parse the syntax and how that interacts, for example, with our data flow framework. And that is something that I would like to see an op definition might clear up all the questions it might not, and at that point I'll come and say, oh, maybe you can design it this way, and then we iterate that maybe there is a change in design. So that's where but these are easier offline on code rather than in a call where it becomes very difficult to explain than have another call. But I think it is fair to say that there is a good way. It's not like a huge code base that's being dumped. There is a way to make it both not super difficult for you to splice and like not super difficult for us to review.
Okay, thank you very much.
Okay, we will just to clarify the process. We actually don't have a good process now. LLVM established these area teams. Area teams are supposed to have like a technical leadership position. I haven't seen any opposition to this proposal in the forum. I think we will still convene with the area teams. So we can like officially stamp this, and then after that, basically, if you feel like it, you can prepare patches. I do not expect there to be much resistance to the idea of having this.
Who's on the area team for this?
Me, Jacques, Renato Golin, and Matthias Springer.
Okay, cool.
You can also ping people on Discourse or anywhere by @MLIR-area-team. That's not very well advertised, but it exists.
Okay, so I guess that for us concretely, we say that this meeting happened in the RFC, and then we tag the area team and start preparing patches in whatever way.
Yeah, for you, you can prepare patches. I'll do the rest.
Okay, cool.
Okay, question from the chat, where will this recording be uploaded? I will put it on YouTube. I don't know when exactly. Hopefully sometime next week, and I'll post the link in the announcement on Discourse. Basically, Discourse is a source of truth for anything concerning meetings, be it virtual or physical. Okay,